while. A little looser in the jowl, a little longer in the tooth, a little more in the hair. And more significant than all of those changes, we have molded canards, upper and lower halves, molded main wings, wings with a winglet that is attached and co-cured and laminated with the lower wing skin. And we have some processes that we'd like to show you, and I suppose that the first of which should be how to jig these parts and how to trim these parts. So I think I'll start with the latter, trimming. Okay, I just hit the mute button. I leaned against the table. And, ladies and gentlemen, there's our first glitch on this video. Okay, so here's an upper canard skin, and it's been trimmed along the front. There's a lip here. This sticks straight out. I have one like this. Upper skin. Noting first, it's very lightweight, very rigid. Center line is marked. This sticks out 90 degrees. You can look at the end. Can you see that, Richard, clearly? Okay. If you trim straight down, your part will be the thickness of this too long. If you trim straight in, it will be the thickness of the blade too short. If you trim diagonally and then sand a little bit off, you probably have hit the happy medium between the two. There's a part line clearly visible along the trailing edge. Trim to that line. Out here at the end, we have one line, two lines. The line approximately an inch from the depression for your wingtip. Another feature I'm proud of. You trim on that line. Same thing on the opposing end. Your center line mark here will line up with the center line mark on your lower skin, which we'll show you in a moment. You'll get this either in a gray or a white surface, no big deal. Trim your upper skin, as I just described, to the part lines, and as per the description, as to the leading edge center line. Now the lower skin, we've got one here that we're preparing to assemble. The bottom skin is a very clearly marked part line. You can hear and see. Center line. There are, can you see these right here? Sure. We have a pencil here. I could rub them with a pencil so they show up. There's a mark here that's marked OPT. That's optional. That's for left-handed pilots. Left-hand stick. This rectangle here and the one exactly 16 inches from center to center away from it, or where your lift tabs go through. You will cut those out, making slots for your canard lift tabs. Your upper skin trim line is real obvious. The skin comes off diagonally. You trim right in the corner. It being a hair short or a hair long is not important, since your upper skin nests into this joggle. The trim on the back edge, a little different. Oh, let's see, it's a little long. We have a little joggle right here. One of the principles in physics is two objects cannot exist in the same place at the same time. And the upper skin here has to sit into the space that is occupied by this portion of the tab. So after you've trimmed it to length, clearly shown by the part line, you will sand through or cut through the horizontal portion of this to make room for this portion of the glass in the upper skin, carbon fiber, excuse me. The tip, on the other hand, the leading edge, no such condition exists, no problem. You'll find that it drops right into place. So we trim to the joggle on this edge, to the part line on the outboard corner, and to the part line that you'll clearly feel and see along the trailing edge of the S channel. We recommend the use of a oscillates 20,000 times per minute. It's spelled F-E-I-N. We refer to it as a fine saw. The blades are expensive, but they last forever. They generate very little dust and create about a 20,000th kerf when you cut. The thinnest cut we've seen thus far with any tool we've ever used. You notice that there's different surface conditions between these two. This one, the primer was pretty young when we laid up over top of it, and it sunk into the surfaces. Does a great job for filling pinholes, no better, no less so than when a surface is allowed to cure a little longer before we laminate over top of it. But neither one is really a problem. And the lack of pinholes we hope you'll be thrilled with, as well as the fit of the upper and the lower skins. Okay, I'm going to have Richard shut off here in a moment. We're going to show you how well your parts will fit together after they've been trimmed. And we have not gone to our pile of Canard parts and selected the ones that fit well and the ones that didn't. So, Richard? Okay, start off with some things that you may note about your Canard. Some of you may see a build up here at the end, rather thick right along the end. It's not really a concern. There's no load on the wingtips as it is. In spite of that fact, we've run our spar caps, unlike the original Canards, all the way to the end. So you can, if you're not using it as a Canard, you can use it as a park bench or diving board. The individual surfaces themselves are inherently fairly rigid, and they'll hold their airfoil shape, so no type of airfoil fixture will be required to help it hold its shape while you do your assembly. The same is true of the lower skin. It's inherently very rigid. The caps run all the way to the end, not only for because we could, it helps stabilize the part so that it makes the part relatively self-jigging. There are two screws holding this Canard to these pieces of Doug fir. The Doug fir pieces are clear. You go and select them yourselves. This is a 10-footer. We bought this as a 12-footer. 10 feet is plenty. You don't have to have it go all the way to the end. This is not going to bend or flex unsupported. We have two drywall screws holding this to the forward portion of the jig. They're 1 inch long, and they go through this surface and right into the intersection of this corner, so that when tightening the screw, it does not distort the shape of the lower airfoil surface. I'm going to remove the bottom here, this other screw, and I'll show you the dimensions of your part. This one's been trimmed as we described before. We need to straighten out the back end of this one a little bit. You might also note that there are, on occasion, we have a few minor imperfections in the surfaces along in here and in here. The primer is actually bonded to the laminate in spite of the fact that it seems to be sucked in inside of dimensions. No sanding is required before doing a fill. These primed surfaces are still chemically active, and micro will stick directly to them without any kind of sanding or prep. Fill them, sand them to shape, they'll fill up the pinholes real nicely. That is not generally the condition most of the surfaces. You'll just see it in a few small spots. Misha, would you grab me a measuring tape, please? This is a 1x4 Doug fir with some 1x underneath it. This is approximately 5/8 to 3/4 of an inch thick. Misha, a regular measuring tape with a standard end on it. I'm going to give you the dimensions. First of all, you started off with your jig table, so you haven't started from scratch. The jig table, you want at least one edge of it dead straight, and you want the surfaces flat. Working from this surface makes jigging, assembling the jig very simple. This is a 1x10, which is actually 9 1/4 inches wide. And if I remember correctly, it is 10 feet long. In this case, it's 10 foot 1. You should have this surface parallel to the table, and it sits above the top of the table 2 7/8 of an inch. The distance between these two is 8 inches precisely. You take a piece of the same 1x stock and you screw it onto the front face so that the leading edge of the canard butts directly against it. The trailing edge will sit right back here on the back edge of this piece. The final resultant height of this is 4 3/16 of an inch. We step outside the building and we look at these two surfaces, and when one disappears behind the other over its entire length, the two surfaces are precisely parallel, ensuring that your canard has no twist built into it. When I put this down on this surface, take my center line, which is marked here, and I put it on the center line of this. I pull it up against the surfaces. I take a number 40 drill bit, I line it up with that edge. You can sight from the end as you drill, and you hit the edge perpendicular to the surface and run the drywall screw in. I'm only using a 1-inch screw. And if I have this right on center line and pulled firmly against the stop, Richard, can you pull a close-up on the stop? Notice the stop does not extend above the cleft line that the upper skin drops into. Oops, one more drywall screw. Okay. These two screws, oops, excuse me, pardon me. There'll be times that you want to take this. Centers of these openings are 16 inches apart, allowing me to reach in, hold the lift tab up against the shear web, and position for final bolting in place before I close this structure. We'll get to that at some point here in the very near future. Okay, upper skin. Center line. I have done nothing to modify the shape of this part so that the two will fit. But the parts fit precisely. They're guaranteed to fit this way. That's why you bought a molded airplane and why you bought molded wings from us. Clicos. I started off by popping a clico in dead center, then going to the tips, each end, having that distance, and then having that distance. So I have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 clicos on this leading edge. And with the way it fits, that should be all that you need when you go to bond this puppy together with flocks along the leading edge. We'll be back to you in the next section, for the next section in a moment. Vocal? Before we go any further, and I know that some of you are probably going to say, hey, you didn't really talk about that jig very much. On this particular piece of 1x4, we ripped some 1x stock that we had to get it to stand up, and that piece of 1x stock is about 3 feet in length, and it's on each end. There's nothing supporting this piece in the middle. There's 3 drywall screws running they were 1 5/8 long, number 40 drilled, essentially making an L out of this structure. So 3 drywall screws in the bottom, pulled up tight and flush on the end, and then that leaves this L portion sticking out for me to drywall screw into the top of the table, both on both ends. This piece, as we centered it, we got one end 2 7/8 inch high. We drilled number 40 again, and it's because the dug fur is so hard, ran 1 screw in. Then went to the opposing end while another person was standing outside and looking so that they could see these 2 parallel surfaces, or nearly parallel. Then I would get this end, the height that I wanted. They'd say, spike her where she lays. I would drill the hole and drop the drywall screws in. Then there's 2 holding this up at the end of the 1x10, both going in through the dug fur into the table. Doesn't have to be terribly substantial, just enough so that it doesn't allow the leading edge to go any further than it does. And then I dropped in 1, 2, 3, 4, 5, 6, 7 drywall screws tapering in height across that board. That's all that's holding this on. And there are only 3 screws holding the back of this end and 3 here, so we have 6 screws holding this on. And again, to cover this just briefly, the distance between the two of them is 8 inches. The height above the table surface for the forward piece is 2 7/8. And the height of the rear piece, if I recall, was 4 1/8. And we'll get back to you with the next section in a moment. Well, we're back again. Following morning, figured that we better show you some of the actual trimming that we were talking about and the tool to which we already referred. Please excuse the noise. Oops. Okay, we plugged it in. Don't catch it. 20,000 small oscillations per second at about 20,000ths of an inch oscillating per second. And Misha's going to follow me to the area we're going to cut. You have on these surfaces the scored, not scored, the embossed surfaces scored into the tool. Now we're going to cut. I've cut just a little bit beyond the marks. It's not critical here. The load forward of the shear web and forward of the spar caps is actually pretty minimal, and precision here isn't absolute. We're going to take a die grinder and we're going to grind this out. We're going to make it a little larger than the marks. These two pieces, these two depressions here, these two cutouts, are 16 inches apart. And you might encounter the front face of the spar cap. I want you to listen to this, and you'll hear a change in tone as I get a change in density. That's spar cap on the surface. The lift tabs are going to go through this lower skin and pick up the forward face of the shear web, which will be bonded between the upper and lower spar caps with reinforcements, and shear web glass is tied in as well. We'll get all that done. You notice we've also, wherever there's a hard point position, ones that we're going to use, we've drilled on those centers back here at the crown, right in the middle of the radius. We're going to do that. This one says OPT on this side. We're not going to use that one because this is a right-handed airplane. We're going to drill this one. The others are drilled as well. And last night I pointed out some imperfections in the surfaces that can be filled with a mixture of West 105, 205, and micro balloons. Minor. They're bonded to structure. They've sucked in. We're not exactly sure why, but we know that from cutting cross-sections of these kinds of areas is that there are no voids and no structural concerns. So you needn't have any as well. They take very little time to fill. We've trimmed the trailing edge. One of the things that I would recommend is taking a straight edge, clamping it to just behind the part line, and then cutting right up against the surface. You have to be very cautious. Don't slip. And if you mess up one, the opposing skin, if it's correct, you can use as your final trailing edge. Now we're going to take a die grinder, and we're going to grind out these depressions. Change the cord. A bit that looks like this. It's 1/4 inch, it's carbide. You got that, Misha? Visual? Okay. Wear glasses, please. Stabilize. Now, whenever performing something like this, whenever you go into a hole, the bit's going to walk. That's how you cut your slot. A little oversized, no problem. We'll be back to you after we've cut the slots, and we'll go on to the next process.
Good afternoon. We're back again, and now that I've got my side jigged in place, we've been using Misha's. I want to show you where you need to send and some of the things that you will find in your kit. Hopefully not the mess that we have here. It'll be either 1 or 2 ply on either side. PVC or polyurethane. It'll either be greenish in color or it will be blonde in color. It'll be oversized. And remember the notches that we cut before? 60 inches on center. We're going to set this up about a 1/16 of an inch aft of these slots, and we provided you with some patterns and some triangles to make triangles that you will bond to the front face of these to set up the appropriate angle, which will result in placing the tabs that tie against these surfaces. It will put them in the right place. I would recommend putting these right in just outboard of these 2 tabs, and then 1 at each end outboard. And you can just super glue these onto the tabs. Before you do that, you will trim the underside edge to match the surface of your bottom skin precisely. Then you will sand 1 inch forward of the aft edge of the hole. And for those of you who have done this before, you sand until you're absolutely certain that you've removed all the gloss. It will go completely carbon flat black. There'll be no gloss like you see here. Can you see that, Misha, in the tape?
Yes, I'm very close.
Okay. And this is very flat, and then you go 2 inches aft here at the center, tapering to 1 inch aft here, 3/4 of an inch forward. And the reason that we do that is very simple. The load, the lift that's produced on a standard wing, is parabolic. Lots of lift in the center, dropping off to next to no lift at the tip. So the tip sees very little load. That's why you can see that the spar cap trough is full here, and here is quite a depression. It's because the spar caps are relatively thin, where the loads are light. So we're going to treat the shear web the same way. We don't want to carry any weight that we don't have to carry. So the structures have been engineered to handle the flight loads in a tapered fashion, much the way the lift is tapered. So we're going to have more shear web transmitting the shear loads and compression loads in the middle and less at the tip. That's thus the 2 inches behind the shear web, approximately 1 inch forward, down to 3/4 of an inch here and 1 inch behind, so that will be tapered. And we can look right over here at Misha's, and we're going to pan over to his Canard. And if you'll notice, he's got 3/4 of an inch ahead and about 1 inch behind. The shear web layups occur at the back end, here, here, here. And when he gets ready to do those, we will have his Canard, pardon me, it's already getting substantially stiffer than it was. We'll take his Canard, the layup, and set it up like so. And we'll do the layup on aluminum foil, and then fold it, put it in place after we've wetted the interior and applied flocks in the appropriate places. Drop it on the back side, put resin on the aluminum foil, rub the resin on the aluminum foil, trying to remove air, and then pull the aluminum foil. You'll do the layup on a flat surface in standard sequence. And that'll be called out when we actually proceed with that process. And in that sequence, essentially, your layup is in reverse. So we do the standard layup, and then we cover it with aluminum foil, we flip it over, we peel the first aluminum foil, then we fold it and you drop it in place, resulting in a layout that is in the correct sequence on the surfaces. We allow that to cure, we trim, we back drill through the holes that are already in the shear web, which we haven't covered yet, because when I go through this process on this next shear web, I'll show you the insertion of phenolic hard points, the non-compressive members here, reinforcements in this area, and the actual T-taping process that you see here. But what I really wanted to do was point out the tapered nature of his shear web. Get back to you, number one, recorder.
Okay, good morning. You're going to need two things. You're going to need measuring tape. I like the digital one. This one's not digital, in decimal inch. A pencil, pad of paper. I'm going to try that real quick. Dun, 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 dun. And record these dimensions. We're going to start with, I'll give you the dimension for the length of your shear web, which at this stage we haven't produced any number of in a production fashion. 121 and an eighth inches in length is the length of your shear web form. Now the center line of this, measuring to the middle, will be 60 and 9/16 of an inch to the middle. The width of this puppy is 2.5 inches. It's going to be reduced to about 2 inches in the center and about 2 3/8 out at the tips in thickness. That's because your spar caps are thick in the center and much thinner at the outboard end, making this an hourglass shape over its entire length. These are 3.5 inches wide. They're 1.7 inches tall. And what you do, if we haven't produced these for you as you see them, they may, when they come to you, they may be phenolic strips and bagged and laid up all in one shot and sent to you with your phenolics in place. We're hoping that that works out, but it's a constant juggling of trying to make money with this and not working at doing so much work that we make no money at all. You may end up doing this. If that is the case, you will cut out a 1.7 by 3.5 inch cut through one skin only. You have a rough and a polished surface. This is the polished side. We don't want you to cut to the polished side, cut to the rough side. And as I mentioned before, it's 8 inches from your center line to the center line of this phenolic. So cut, 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 remove the glass, scrape out the foam, sand the surfaces of the glass clean, take your 1/4 inch phenolic, cut it to the dimensions that I just described, sand both surfaces, brush West resin into the depression, West resin onto the 40 grit sanded phenolic surfaces, put a bead of flux down the middle, about 3/8 of an inch to 1/2 an inch wide and about 1/8 of an inch thick, and have this on a flat surface. Plastic underneath. You can see the ripples here where the plastic was. We had a plastic piece about this long, and we put it underneath, and then after we squished the phenolic in place almost all the way in, but not quite flush, there was flux coming up around the edges. We scraped off most of it. Took 1 ply of glass bid, plus or minus 45, to the central axis, wet it out with West 105, 205, and then folded the plastic over top and put a piece of flat aluminum or melamine or particle board or whatever, something that's very flat and smooth, and then weighted it with about 25 pounds of weight. We did the same thing on the opposing edge here. This particular shear web was about 5 inches short, so I tagged on a tab right here with 1 ply of bid on either side. This isn't very critical. The loads out here at the end are darn near zero, so don't be too much concerned about that. Both faces of this will be sanded in their entirety in preparation for the shear web. Glass is going to be laid up on both surfaces. The lift tabs are placed over top of these phenolics. The holes are going to be placed approximately 1 inch from this edge and then drilled before we do any installation of this whatsoever. We'll be back with you in a few minutes and show you that operation. Thank you. Okay, we're back again. What you have in the foreground, actually both lift tabs, as you can see the pencil line. Oh, we have to zoom here. You have to excuse me, I'm doing this shot by myself. This pencil line here is 8/10 of an inch from the bottom of the phenolic, the surface that contacts the shear web. This is a lift tab that has not been tapered yet, but the holes are exactly like the ones in your lift tabs. This line is, as I said, 7/8 of an inch from this edge, 0.875. Both lift tabs are done that way. They're clamped. The lift tab is perpendicular to this edge, and they are the center hole 8 inches from the center line. Let me see if I can see that. Yeah, the center line to the center of the center hole, 8 inches, making the two lift tabs 16 inches apart on center. Now we're going to take these over to the drill press, and I'm going to drill all of the holes. And if you're thinking, well, isn't it going to egg the holes out a little bit? It'll increase the holes ever so much. Redundancy, and the fact that when they're assembled, there'll be a small amount of epoxy on the bolts. Will fill any gaps, any looseness that you might see. Let's get a close-up of this. And really, really close. Bolts, center line. Seven-eighths of an inch again, 8 inches on center. And we're back. We've just drilled the holes and worked out really easily. I don't think they even egged out the holes even slightly. There's the first one. And make sure by looking at the... Yes, looks good. Oops, back the wrong direction. 3 holes. On the money. Even absolute perpendicularity here isn't imperative, but preferred. But remember, the original lift tabs were 1/8 of an inch on the long easy and 1/4 inch bolts. We're 1/4 inch lift tabs, and we are 5/16 inch bolts at the point of attachment. And after recently seeing a Canard ripped out of an airplane, and lift tabs were undamaged, and these areas completely uncompromised, we know that they're way overbuilt. So this is what to bond this into the Canard. We'll be back to show you that on the next section. Oh, first of all, we're sitting with the phenolic face here in glass about 1/16 of an inch from the aft edge of the hole that we cut earlier in the tapes. Center line is, we've transferred the center line that is visible and audible to the line on it. If we find that the lift tab doesn't fit in here when the holes line up, we just widen out the slot slightly. Now we've provided you with drawings of this form, and we're going to superglue this form, just a little bit outboard of this surface, and you notice the back edge isn't touching at the moment. We're going to swing this forward and let it contact. Well, this form places the incidence angle of this shear web form correctly, so that when the lift tabs are bolted to the face of the F10 bulkhead, we end up with a resultant 3.5 degrees angle of incidence, Canard, and that incidence means specifically incidental to the longeron. The longeron flies at 1.5 degrees in level flight, which means that we are flying at approximately 5 degrees in level flight. And the wing is flying at 2.5. So this is flying at a much higher angle of attack, and it's flying closer to its stall. You can do with that whatever you please, but here we go. Now, another thing I want you to note, Richard, I want you to move outboard, and I'm going to hold the center in place, and I want you to notice that we're not touching the shear web here. I'm going to fill that minor gap with micro. I could trim this shoe head precisely to this shape and work myself for 15 minutes, half an hour, making this all fit, and for what? A micro isn't going to add that much weight. And I'm going to have these same forms outboard, which correctly position me parallel to the leading edge. More forms. And so it won't really matter that I'm not touching there. We're talking about a very small amount of micro for a small portion of the canard's length or span. So now, with everything in place here, I will get my super glue. Hope that the wind doesn't blow me down. Oh, blow me down. Okay. Place the super glue liberally on this surface. This is the slower material. Now, I don't really want to glue to the canard, for obvious reasons. The Zeep Kieker, squish, squish. Bingo, that sets me up here. Now I'm going to do one on the opposite surface here. There. A little further outboard. And again, about 1/16 of an inch from this edge, and that's to make room for a buildup of glass that we're going to put on here from this surface up the face and under the forward edge of the shear web. We'll be reinforcing it on both sides of the shear web cap, but we need room for that material. Okay, coming up, I'm going to fudge it a little here. A little super glue, check the surfaces. These have been used on 4 different canard assemblies. Misha's used them, Sampuma's used them, the Estonians used them. They're nice to have. I'm hoping you can see that, Richard.
Shadow. Yep.
Okay, and it is kicked, and we have now a good fit. I take my measuring tape, once it can be found. It doesn't have to be a measuring tape. We can use the fudge factor. Go out here like so. And now I'll go to the outboard end with another form. Place this out here. That's right where it goes. I could just dribble super glue down in there and kick it. I'll show you how that works too. And being the lazy guy that I am, check it again. Is it visible, Richard?
Yep.
Okay, we're in the same place. I'm going to mark it both sides. Black on black. That doesn't work very well. Now this seems to have dropped right down into the depression. Let's see what the other side's doing. Yeah, right on the money. I could open it up a little bit, let it run down between the 2 surfaces, which is doing handily. Come on. Ooze on down. A little more. It won't cure until I kick it. And check this. We still have the gap there. And now kick. And it will go off instantly. Now I'll repeat this on the other side. And then I'll brush resin on the bottom edge of the shear web, brush a small amount of resin on the wing surface itself, and I'll put West 105, 205 micro on the bottom surfaces and squish. Let that cure and prepare to do the T-taping that you've already seen on Misha's canard. We'll be back here in a bit. Okay. We go again. 105, 205. Our friend Misha dug out the foam for 1/8 of an inch, filled it up with micro, but quite frankly, it's completely unnecessary. The sound of freedom. Alright, we're going to do this down its entire length. Now it's a cool day. It's about 68, 70 degrees. So we don't really have to, we don't have Beelzebub breathing down our neck at the moment. So we don't have to go like a house afire. But after I'm done with this, then I come down here, ooh, squish, and right along this same section right here. How can I tell where it goes? Because I know it's right where the bevel edge of the spar is. I've got to sand this section again, so I'll go a little wider with this resin than I need it, but not much.
On the side of the shear web?
I'm doing the bottom side of the shear web already.
Either.
Okay. So that's what we're going to do here. We're going to just finish this up all the way out, cover with micro, stick it down in place. We'll be back to you when when we turn what's left of this to micro, which should, it's not going to take a lot of micro, and since it's cool, we have enough resin here with one shot to wet the entire bottom edge all the way down, both on the wing and on the shear web, and turn it to micro and still have material left over. Back to you in a moment. Now we're taking that shot of resin, turn it into micro that is pretty firm, and I've spread it out so that it doesn't overheat. I haven't got much time left. So here we go. We're going to stack it up on top. And hope that we got enough micro in this cup, as I predicted and suggested, to actually do what I said it would do. You do need it stacked up. You want it to fill any voids. You're creating the extension of your core. After I get this completely covered and set in place, I am going to just lightly tack our little fixtures here to the surface of the inside skin so it doesn't move while it cures. A couple of hours from now, if the day warms up here, which it has been, this is late August here in Los Angeles. Now those of you who want to get anal, really anal about this whole process, you can put flocks here where the tabs are, but the load isn't going through the edge of the tab, so I wouldn't worry about it. It's just a filler. Make certain that you have contact. The real work is being done by the shear web layups that we're going to be doing subsequent to this application. And you might be mindful of the fact that in the middle here, we know we've got really good contact, and at the ends where we have a little bit of space. So you can have less material here in the center, more material outboard, especially if you're running a little on the short side for your micro. Notice the shearing action that I'm doing with my stick here, cleaving off the material, borrowing from Peter here and paying Paul every other swipe. It's also how I transfer pressure to the edge to make certain that I'm really imparting this material to the surfaces. I'm running right down to next to nothing. I'm going to have enough to do the job. After I get it tacked down, if I feel that I have maybe a few voids, I can scrape off material from my midsection where I know I have plenty, and come back here and push it into the corner. Because since this is straight and this surface is somewhat tapered, I can push the material in from one edge and assure that I have no gaps left. Okay, we are nearing the moment of truth.
How about that movie star smile?
Okay, here we go. Flip side, center line, center line. We go right to here with that 1/16 of an inch I was talking about before. And I'm going to glue this down before I go any further. Super glue. Stupid glue. I resemble that remark. Hey, you get the super glue? I got it. Here. 1 bottle of Kicker.
It should be in front of the kicker.
You notice that how I'm not hurrying anymore. It's because now that I've got things in place and I've got the micro spread out, it's not going to kick off on me all at once. We'll be back to you in a moment after we find the super glue.
Yes.
Okay. Well, I've got my gap. I've checked my dimension. We're still cool. So here's the super glue. Watch, I'm just going to drip it into the corner. Doesn't have to be a lot. Kick. Give it a moment before you let go. And if you're really worried, go to the other side, maybe a little further aft. A little kick. You know, the internet, the way it is, you'd expect that someone would have said by now, you have to worry about that interaction between the super glue, the zip kicker, and the epoxy in the wet condition. It's explosive. No such things have occurred yet, so we're not worried about it. No one has indicated any real problems. Oh, isn't that nice? Right on the money. Now, I'm pushing down a little bit here, so it looks like it might even need it. So I'm gonna glue it at the back and at the front. On this side. Sorry you can't see it.
You can see now.
Okay. Kick, kick. Boom, boom. Now the precise dimension 4.5 on this really isn't that important. This is just a compression member. It appears that all the gaps are filled. I've got extra material in the back, which we'll show you in a moment, and I'll show you how I spread it around. We're not going to torch you with this any further. We'll be back with you in a little bit and show you some new processes. Okay. All right. Now then, Richard's got me in focus here, down here. I'm going to put my finger in there. And we're going to push it underneath. I'll make sure I have no gaposis. If you wonder where that phrase comes from, gaposis. It's an obscure Steve McQueen movie about a condition he referred to as scabosis. That's how he justifies having a fan at his desk, when most lowly military people who sit at a desk have no fan. Good? He tells the general that it's to prevent a condition known as scabosis. So, thus, gaposis. So, now I'm observing on this side and making certain that I can see this stuff being pushed through the other side, ensuring that I have no gaps. And we won't beleaguer this point any further. Thank you very much. Bye. All right, we are back here for just a moment. We don't want you to leave this stuff behind. Remove all of the excess material, both from the lower surfaces and from your shear web surfaces.
here. Make it really, 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 really clean so you don't have to sand this stuff off later. If I had been thinking, and I wasn't, I would have pre-sanded this surface and this surface before putting this down. It's so much easier for me to sand this on a flat surface on a table than it would be otherwise. So please do that, and we'll be back to you in a moment. Okay, if you notice, here's the material underneath. Let's just manipulate it a little bit. It's push it, squeeze it down in there. Just smooth it out, make it look like it happened intentionally. And there's a little bevel there, so it's going to be a little more difficult to clean up. If you want to fill up the gap with micro, it's certainly okay to do so. The major shear loads are on the back side, and we're going to have a small layup here in the corner and one up at the top side. So it's okay to fill that up, and you can do so with micro. You might have to let this cure a little bit before you do that, though, because it's moving around some, and I don't want to disturb the cleanliness of the backside. So hold it in place, do a scrape, and then come back in a little while and do a subsequent fill-up. Okay, now we've got we've removed our supports. We've sanded up about 3/4 of an inch. Now we're going to take West 105, 205. We're going to wet this whole intersection. My micro is still active in this corner. I'm going to put just a teeniest bead of flux in this corner. I'm going to take my 105, 205 that I'm going to have left, turn it into flux, and then I'm going to lay up a tape. You can lay up your glass tapes on foil if you want, like Misha across from us did, and then stick them in the corner. I'll start I'll put the flux in the corner, and I'll show that on tape in just a moment. I'll be back with you in a second. Okay, we took what we have. Notice it's a little bit on the reddish side. This is 105, 205 that has begun to age a little bit. I don't need a lot in here, just enough to fill the depression and give me a transition. You notice I'm also starting to turn black. I'm picking up some carbon fiber dust left behind. No big deal again. So I'm going to do this all the way down with a tight little 1/8 inch radius, maybe a little less than that. It's one of the nice things with wet layups that you can do that you can't do with some other processes. Is you can have a very tight radius. So let me give you the final look that it should look like before I abandon trying to show you how it looks. That's a pretty good representation right there of the diameter of the radius. There's a scale of things, my fingers and this. This is too big of a radius. Don't leave that much material in there. We'll be back with you in a moment when we go lay down the first layer of cloth. I'm applying the resin. I failed to videotape the process of applying the cloth. So I'm wetting the inboard end of my first layer. Richard, you got a close-up on this?
Yep.
And this is 105, 205 going off like the hammers of hell. Now I take a strip that I cut at 2 inches in width. I will allow it to change its shape, which it will do anyway, whether I allow it to or not, up to about 1.5 inches. Now my taper's cut this way. This is my selvage edge. And before I put this down, I'm going to wet the surface a little bit, trying to stay away from my flux so as not to dilute it. Helps it stick up as well. And it appears that one piece of cloth cut at 2 inches in width, when stretched to about 1.5 inches, will go beyond center line by about 1.5 inches, 2 inches, which is cool. It's fine. Grain orientation here isn't absolutely paramount, since this is the redundant portion of this program. In the front of this is not bearing
substantial shear loads on the front face and probably could be eliminated altogether with no problem. But I don't like having a glass that is not transmitting its shear loads to a surface. So we're addressing that here by putting this tape in. And you notice it's only one ply we're going to apply. We'll put that resin down. Make sure it's covered all the way. And now the tape. I've got that other one out there, but I'm going to use this one. This one doesn't seem to change shape quite so much. All right, I don't want to narrow up too much. I cut it at 2 inches. I want at least 3/4 of an inch up each face, 3/4 to a half an inch. Can you see that clearly, Richard?
Yeah.
You get it to sort of span across there at 45 degrees. And after you get it in position, then you very carefully press the middle into the corner. Don't worry about what happens here where the hole's cut. This will get covered with 5 or 6 plies of bid that laps this face up and underneath the T-tape later. Just take your time, handle it carefully, and try and maintain a constant width from end to end. As I mentioned before, all you need is a half an inch of material on each surface and you'll be doing just fine. You can shoot for 3/4, no problem. You don't treat this roughly. If you handle it roughly, you will stretch it out. Handle it gingerly, carefully. Am I starting to sound like the Galloping Gourmet? Take 3 eggs, fold in lightly. Scissors? Good deal. Okay, so that is the application of the dry tape. As I said before, if you wish, do it on aluminum foil. And then as you apply the resin here, just carefully dab it in. This is wetting out much faster on this side than it did on the other because I pre-wetted this. And that's something I would advise doing. When it's black, it's beautiful, baby. It's perfect. And don't mix more than 1 shot at a time, especially if it's over 70 degrees. You will waste resin. Okay, we'll be back with you in a bit. Okay, we're getting the last little bit of bubbles out of this thing. I get the glass heated up first, and it will take resin very, very, very quickly. Don't be careful about heating your brush up because West 105, 205 is not very tolerant to that. But if you heat up the glass just prior to, you don't heat up too much. You can get it to wet out very quickly. I'm almost done with this. Make sure it stays in the corner. You notice how small that flux corner is, and the cloth is laying right into the edge. You get all the air out of it. When you stipple, you'll create a little bit of foam. After you've created the foam, break the foam with strokes. Check all your edges. And allow to cure. After cure, come back in, just break the corner so you don't lacerate yourself later on. We have a few ribs to put in the leading edge. Check for bubbles. No bubbles. Okay, done with this. We'll be back with you in a bit when we get ready to put the T-tape on the top side. Okay, back again. When last we were doing exposures, we bonded this down with micro, and I'm going to move Misha a little closer so he doesn't have as much of a shadow.
shine down in here, Misha. Good. What we did is after the micro partially set, we scraped out the excess that was in here.
Okay.
And then the surfaces having been previously sanded, and I hadn't, and I will recommend it to you guys here now, is to sand this surface in its entirety first. Both sides, bond it down, and then put in one ply bid. You know, it's about 3/4 of an inch here, 3/4 of an inch here. A little bit of flux from there to there, just a little 1/8 radius, maybe less, to fill in this groove. And come on down here. You'll see I've already done this area, and I've cleaned out the groove. And the one ply runs full length. Now, at the center, the T-tape, and this was worked out by Misha, the amount of opening from the inside skin to inside skin at the center is about 2 inches. So I took a straight edge here, placed it on center line, and I clamped it. Then I went down to this end here, and I measured it from this surface here, not the spar cap, from this surface. Okay, I'll move my finger. Misha, was it to the spar cap or was it from the front face up to here, 2 3/8?
From the spar cap.
From the spar cap? You sure? It wasn't here?
2.5 inches from the spar cap.
2 3/8 is what I measured. Okay, all right. I measured yours spar cap in a different way, and then I just put a pencil in here, pushed it against the surface, marked it. If this thing isn't perfectly straight, it does not matter. You're going to custom fit your ribs in place. Minor discrepancies here don't matter. Okay, so now I take my fine FEIN saw, oscillating saw, and I cut this off. It's hourglass shaped to reflect the thicker spar caps in the center, the thinner spar caps out at the tip. And if there's, you can go 1/8 inch, you can even have as big as a 1/4 inch gap between here and the underside of your canard, and it wouldn't matter. You're going to stack micro on top of this surface when we do the T-taping operation, and we'll be back to show you that in a little bit. Thought we'd show you a neat trick for using the vibrating saw. And you put, rather than drawing the line, or after drawing the line, you put the clamps back on, and just let it rest right on top of the straight edge. Howdy. I've already cut the front face, which makes the cutting to the backside much easier. See, clean, easy, fast, not particularly quiet. My apologies. I had Misha fold his sandpaper and go in here and remove 3/32, 1/8 of an inch of the foam to improve the bond between the micro and the T-tape. This will help ensure that when you go to pop the top off, for whatever reason, if it tries to debond from here, it will be resistant to doing so. It doesn't really add any strength to the total bending strength or shear strength of the canard, but it does help eliminate the possibility that the T-tape will pop off when you remove the upper skin. You don't have to be too careful about preparing this edge as long as you increase the surface area, which you're doing. So proceed from here. I'll make the other cut, and I'll show you how it all fits after I get to that stage. Back again. My sincerest apologies. It appears that because of a condition that I didn't recognize right away, that this height at this inboard end is almost exactly what it is in the center. And it's partially due to the fact that I allowed the forward edge of my shear web to sit up onto the foam portion just forward of the spar cap. And this is all the same thickness. So this is 2.1 at the inboard end and 2.0 at the center. That's because it's all sitting on top of the same foam. So 2.1, 2.0, the whole length is probably going to be just fine. Start at 2.1. I got just a touch of a gap between here and the inside of my surfaces. That's okay. Now I'll resand this. I've also removed the foam just over top of my phenolic, so I have a solid filler between here and the underside skin. When I T-tape this, it'll probably be flocks. And I put the top on. It fits. Seems to be have no problems fitting at all. I think we'll show you a close-up shot from the inside. It's fully closed, and I can play with it. It's not, because the spar cap is so thick here, it doesn't flex much. I can get it to flex here and come down and hit the shear web. But we don't want to change the shape of anything here. We don't want to weight this thing in place. If you do, you just bump it, play with it, get it to settle, and then leave no weight on top of it. Maybe at the trailing edge, definitely click on the leading edge for the final cure. If Mishik, you can position yourself and look in the inboard end here, you will see the gap and distance. Mishik's going to pull up there and side. Get that thing from lower, Mishik. Get to the upper surface, Misha, up here. Look up, get down. Okay, there you go. And it's a little too much light.
No, perfect works.
Okay. And we've got just a little, I'm going to move this, see this? We've got a gap there.
Yes.
And that's going to fill up with micro balloons. That's how it's supposed to look, folks. And we'll be back with you in a minute when we show you T-taping operation, probably from the same POV when we squish this down. We'll also show you the taping of this upper surface here with 3 plies of bid glass, lapping 3/4 of an inch forward of the shear web and 2 inches aft. Okay, back. We've got everything trimmed on the shear web, sanded both sides of the shear web. Get it pre-sanded, get everything ready to go. Even sand the spar cap on the bottom surface before we start, and that way if we have any drip resin and it gets smeared, at least you get that resin bonds to the surface, so that if you don't sand it off completely, you don't have to worry about subsequent bonds of the things on top of it. I have about 1 inch of this duct tape ahead of the spar cap foam transition. And then I lap about 1/8 of an inch of the 2 tapes. So this one goes down first up near the leading edge, and then the second one. We're not going to cover the entire spar cap area with a T-tape, and the T-tape is going to be tapered. We're not going to taper it just yet. We're going to leave it a full inch ahead of the shear web and a full 1.5 to 2 inches behind the shear web. And after we pop it free and trim it, it'll go from 3/4 of an inch ahead of the shear web to just slightly ahead of the shear web at the tip. And the same thing at the back end. It'll taper. It'll be about 3/4 of an inch behind the shear web, and we'll go to about 1.5 inches after the shear web at the center line. And we showed you that earlier on the tapes. I do hope you review this tape in its entirety before you begin the process. Thank you. All right, we're mixing 105, 205, and I've got 2 shots down, and it's a little warm, so I've got to get this stuff down really quick. Make it larger than it needs to be. We get the resin in place, and then we're going to lay the tapes. I'm going to just do the first one and show you what it is. It's going to be 3 layers thick. And you say 3 layers, why 3 layers? Well, if I did 1 layer thick, it doesn't do the job it's supposed to do, because all this is a form that holds its shape for me to lay out the real shear web stuff up underneath it. And if it's not stiff enough, well, we defy the purpose for doing it all together. It's part of the price we pay for doing the hollow wing process. I have some hairs. Bing, gone. Okay, so let me get the first tape here. I have them cut. I cut them at 3.5 inches wide. We don't want them to change shape. A little wider is better than narrower. I'm going to come up right close to the edge of the duct tape up at the front end. And you notice how I play with the width as I go. I open it up, open it up. Not hard to do, but you'd be surprised how many people just can't get a feel for glass. If I want more width, I have to lose length. That's the name of the game. Do not lap beyond your duct tape. You will have a very difficult time removing your tape. I'm going to wet this out real quick. And I don't mean that figuratively. Don't spend your time trying to wet the cloth. Let it do its own thing. Time will be the best wetter of the cloth. If you can get another individual to work with you on this process, I'm going to move here. I got to move 45 degrees from it, or from the other direction, 45. But you notice it's wetting out by itself. 2 plies is workable. Two plies. 2 layers, 2 shots of 105, 205 is workable as long as you are familiar with the process and you can really get it down fast. Next, notice I didn't bother cutting off the selvage. This is the newer weave that has the really ultra thin and sheer selvage, eliminating the requirement for removing the selvage for those of you who aren't familiar with this new cloth. So I'll get both of these down, wet them out, and then I'll put 3 layers of this down. So don't lap in the same place each and every time. Stagger the laps. And we'll be back with you when we get ready, when this is partially cured and ready to put it onto the shear web form. Back again. 105, 206, because I want to do this all in one shot. This won't cure quite so quickly as it was before. So I'm going to just mix this stuff up, brush resin into the impressions, and you notice I have flocks and micro, 2 separate containers. And what I'll do is brush in the resin, and then take a small portion of that resin and mix it to flocks and fill up just the areas above the hard points with flocks. Again, brushed resin in first. And so I have essentially 3 steps. Pure resin, trying not to get resin down these pre-sanded faces. I'm so lazy, I just don't like doing anything over again if I don't have to. Preferably clean your surfaces first. You notice I got blue foam all over everything. I'll get this brushed in with resin and I'll be back with you in a moment. We mixed the flocks now. We took about 25%, 30% of the resin. Push it in so you don't capture air down at the bottom. Squeeze it in there, all the way to the bottom. Progressively. Don't just go pushing in a big blob from the top because you'll just capture air. So we're going to fill this puppy up all the way. Puppy. Where'd that come from? And after I get it filled up close to the top, then I will peek it up on the upper surface, making certain that it picks up the underside of the T-tape. Now, I'm going to do that on this side, but you guys don't have to watch me. We'll be back with you tomorrow when I put on the micro. Okay, we're done with the flocks. Now we're on to the micro. And we're going to fill up the minor depression first. And after we do the minor depression, then we stack it high. So just fill the minor depression first, just like this. Boom, boom. Good. Full. Then stack it up. Do like that the entire length, and we'll be back with you in a moment. All right, we've stacked it on. We've stacked it on about a good 5/16 of an inch, peaked it high, and now I'm going to brush resin right on the area where this interfaces on the underside of the glass, because the glass has gotten to the point where it's no longer tacky. And then we're going to squish it on. We'll be back with you for that application here in a few moments. All right, I've taken some 206 here, and I'll brush it right in the area where I'm going to be hitting the shear web. This is already non-tack. This is non-tack, but it's still active chemically. It was laid up only a few hours ago. And I've got this wet area that I'll make certain where I'll stick to this relatively dry micro that's peaked up there. Uh-oh. Okay. No, I'm on center line, Richard.
Okay.
I'm only concerned with one thing, right here, center line. I squeeze it down, and I look underneath, and I make sure that I see the squeeze out, which I have ample of. And could you turn that thing off? And then, how's it look, Richard?
Very.
Okay, the squeeze out is there to make certain that you have good contact. Now I drop the clecos in, and I make certain that I have good relaxed contact at the trailing edge. See, this does not have contact, so I just play with it, push it until I have a passive resistance. And we'll be back with you folks in a little while. If we have any other processes to do other than just waiting for it to cure and then popping it off, we'll come by and show you those before we pop the top off. Good morning. We're back again. Now I'm going to do something here that we're going to release the Canard upper skin from the silver tape. And you just heard it release there on the back side. Misha tells me that his didn't want to release. And I'm not finding that to be the case. You can see how that let go. And let's set that up there, and I'll give you a pan on how everything looks. It let go very nicely. Its entire length didn't lift anywhere. I'm going to zoom in on the lift tab area. There. And solid. We don't have any gaps. I don't know if you can see it down here. We'll go to the next lift tab area. But right here, and right here, I can see the edge of the glass that represents the two edges of the shear web coming up. And that means that the top lid here was sitting right on the edge of the glass. I only see that in that one place. There's nowhere else in this whole layup where it shows. So I was right down in the upper skin here. But this is in the middle of the Canard, and contour here doesn't matter. It's inside the Canard deck. So I'm going to mark this for trim, and I'll be back with you in just a few moments. Okay, we're back. We've trimmed, and we're going to show you the dimensions here. This runs 5/8 and the back end runs 0.8 to 0.9. This dimension really isn't all that critical. You can see that what we're trying to do is taper the loads from a great deal of load at the center to very little load at the tip. But if you're only doing 1/4 to 3/8 of an inch, it's almost not worth doing a layup on the underside. So 0.7, 0.8 here forward, and 0.7 to 0.8 at the back. This one reads 0.65 at the front end. The aft end reads 0.9. Now out at the center, and by the way, that is your tolerance. Not extremely critical. Let's bring it up in the center, and I'll give you a dimension out there. Okay. There's the middle of the frame. I'm doing this on myself, so please excuse me, and we'll verify these dimensions. Well, the front we know. It's 0.8. And again, not critical. We're going to go from 0.65 to 0.8 is fine. You can go as big as an inch, but that makes it more difficult to sand, and it really is unnecessary structurally. The back edge runs 2 inches. 2 inches at the center line, and that'll do the job. So trim it to these dimensions, as you see me having done here. Both tips are the same. Then sand the underside and remove the micro and anything excess underneath, and the flocks you can grind out. It's a bit of a tedious job. Get in there with a chisel, sandpaper. Don't sand through the structure. This is a form upon which you're going to lay up your shoe web. If you sand through, not that big a deal, because the real loads are borne by the glass that they were laying up underneath. The only reason you don't want to compromise this is that you compromise the form. Back with you in a moment. We are back. Hello again. You'll notice that we have the Canard sitting vertically and a piece of particle board sticking behind it, holding it upright, allowing me to get to the end so as to be able to get to the micro right in this area here. And I will be getting in there with a chisel and working your way at it. Let me see if I can get a close-up shot here of what your micro looks like. There it goes. And I can take a chisel and a hammer and knock away at it this direction from the top with a hammer. And then I have to get in there and scrape and sand away the excess later. We'll get back to you in a little bit and show you what that looks like after we've really removed some material. All right, what we're doing here is I want you to see what I'm doing to chip this away. You notice my angle here? Well, this is flexible enough where I can bring it back and get right to the edge of the micro. Now, if Richard can get in there and see this, I'm going to then pop this free. Let's see, let's take this, turn it in, fold it out of your way. Can you see it? And what's it trying to focus on?
It's decently focused.
Okay, now then folks, watch. We take a little bite, bing. It's about 1/4 of an inch a shot. Just keep nibbling away at it all the way down. The further I get down toward the other end, use your guess, because I don't have 2 inches of glass in the way. So we just fold it back, fire away. Now later on I'll get in there with sandpaper and I'll tape these edges so I don't cut myself while I'm sanding. And I'll also be able to get in here and scrape this material away from the shear web. They're getting pretty clean. It should take you about an hour to an hour and a half to clean this puppy up. It's not fun. Now I can also get in here like so and scrape, scrape, scrape. This is where the load intersection occurs, right in the corner. So when I'm all done, I'm going to sand the inside of that skin and sand the shear web. Most of it's already sanded. Just take your time, chisel away at it. Bingo. You just keep trying different methods, and what works for me does not necessarily going to work for you. And proceed. Pardon the background noise. Notice that we have fairly translucent surfaces here. And when you start to sand, notice it starts to get white. Let's get you a little more zoom here and you can really see it up close. Under my hand, still translucent. Really translucent behind it. Less so the more I sand. By the time I reach where it's almost not translucent at all, I'll move to the side here. You can see, I can see my finger again. Let me go out, and you can see now. That's about where you want it sanded. Now down at the bottom of the intersection, down at the very corner, is where you want to make certain you don't have any gloss and get a perfect bond, because that's where your load transition occurs. This is right at the hard point. There's flocks in that corner, which was a real barrier to scrape out and chip out. But give it your best, and we'll be back to you in a minute. Well, hello again. Here we are, looking down the C-section here. Notice how clean it is, how well sanded it is. No goobers in the corner. All the way down. That's what you want both sides to look like. This side and this side in the corner. That's where your critical load transition is, right there. Clean it up, make it look nice, and we'll be back with you when we get ready to lay up the glass.
Hello, my name is Mishka, and I will show you actually how to cut the glass for the shear web for the Canard. First what we have to do, we have to cut a unidirectional glass 7715, and we have a 45 and 90 degree prop here, and we're gonna cut 45 degrees along the length, and it will be approximately, length will be approximately 52, 53 inches long this way, and it will be 8 inches wide, not along the filament, but perpendicular to the cut. So we'll put an 8-inch of perpendicular to the cut, and we'll mark it. And at that point, 8 inches right here, 8 inches here, and 8 inches on this side. Pretty good right there. And at that point, we will cut here along this line, and we will have 8 inches by 52 inches length. Also, for the same job, we will have to cut a bidirectional cloth. And what is the number of this? 7725. And in this situation, first cloth will be 20 inches long, right here, 20 by 8. And again, we're cutting on the bias, so it's a 45 degrees. And the second piece will be 40 inches long on the bias. And also 8 inches. All of those pieces will be 8 inches long. And we will proceed with the cuts, and we will get back to you. And you have to cut 8 of unidirectional, and 2 pieces, one again 20 inches by 8, and second piece is 40 by 8 of bidirectional on the 45. Thank you, and we'll get back to you as soon as we cut the rest of the pieces. Hi again. After we cut all our glass, we set up a foil for the length of the whole shear web. Just want to specify that we want you to use the heavy-duty oven foil, which is much heavier and much more substantial than the regular foil. And I want to explain what is that all drawing around here on the foil. This is the center line. As you know, we cut 8 inches width of the glass. However, right here please. What we did here from the edge, we measured 3 inches, and then 3 inches next ply piece, and then the next piece. What it will allow us to have parallel lines along the whole foil, and then we will use only 1/6 inch of material that we need, and we have a little excess 1 inch on each side, and 1 inch on each side, and then we're going to cut it through and make it a nice and even. I want to come to the center line right here. Here's the center line. We already know how many plies it will go and which way they will gonna go. The first will be unidirectional. Unidirectional will go all this way, and it will be 120 inches long. So we'll go 60 inches this way and 60 inches this way. Next, after that, we know we have to have a cloth, unidirectional cloth, at 45 degrees. So what did we do? We put straight 90-45 tool right here, and put this edge along the line, and it gave us a 45 degree, perfect 45 degrees. Because we know we have to put 2 different uni cloth of ply. One will go like that, and the second ply will go like that. And using those lines, it will allow us to lay glass absolutely perfectly, which is absolutely very important. Let me show you what kind. The first we marked 20 inches, which is 10 inches this way, and 10 inches total is 20 from the center. The second ply we marked 20 inches to this side and 20 inches to this side, which we mark at 40. And the third ply is 70, 35 this way from the center, 70 right here, and from the center 35 this way. Total gives us 70 inches. And of course the longest one is 60 inches each way. So that's what you have to do before you start lay the glass. Prepare yourself on the foil, and it will definitely help you when you wetting out the glass. It will just tremendously help you. Thank you, and we'll get back to you when we put in the glass and wetting out. Next step, I want to show you exactly how to place the glass and how to wet it out the glass. Just want to I want you to pay attention that we're using for the shear web in the Canard, we're using structural epoxy. We're not using West systems. I want you to make that a note. We're not going to use a West Systems epoxy for that. Now, okay, it looks like it's nice and mixed here. What I have done here, now, just a minute ago, I want to show you what I've done exactly. I placed one, doesn't matter which way you put first, this way or that way. I chosen to put this way. So here is the 120 mark, and this way it's 120 inches. I placed a glass this way that corner covers my 120 inches right there. And we developed that system here. I put my finger right here on the line where I know my 45, and I pull it, and it places glass exactly at 45 degrees. Look at this. And then I pull it right here. It's perfect, and it's perfect right here, and it's perfect right here. So other thing I want to mention, and I want you to pay attention. We're not overlapping 1 inch of anything else. We're butting it. We're butting 2 pieces. We're not overlapping. We are butting 2 pieces together like this again, and we continue putting 2 fingers on the line and pull, and it places
the glass exactly at 45 degrees. So while I'm doing that, let's say I'll go all the way through, I'll finish that side, I will come back here, and the first thing I will do, just place, wetting out and placing at the 45 degrees right here. What am I doing? I'm dabbing and I'm attaching it, glass to it, to the foil, and then I can come at that 45 and do that. You see what it does? It sticks, the glass sticks to the foil, and it allows me to work, and the same allows me to put the glass exactly at 45 degrees. And of course I do that here, and I do that here, and so on and so on, and I continue. And let me show another little detail. When I put epoxy in the brush, I move along these fibers like that. Look at this. And then I move this way. And what it does, it keeps the glass exactly at 45 degrees. I can do this, and then I put my hand, and let's see if we have a little whoopie-doo here. Very good, very good, very good. And like that, I worked all the way along the 120 inches, which is a whole full length of shear web, like that. And of course, look at this, this is great. See, I move, and I move this way, and then I move this way, and so on and so on. And I want to continue that. Let's say we're wetting out all the way 120 inches of the whole shear web, first layer. The second layer will be it will go opposite of that. And what I mean opposite? It will do that. It will create certain V, as you can see, it's V. And of course, this time I will scrape a different way. Let me finish that layer, and then I will come to the second layer, and I'll show you exactly how to put the second layer of first ply. Okay, we're back. As I said, we finished the first ply of the first layer all the way 120 inches. And as I mentioned earlier, it took more than 2.5 pieces, or let's say more than 2 pieces. In this situation, it's in our situation 120 inches. It came up to 2.5 pieces. And here is the one butt place. Here's the second butt place, and here is the last piece. And as you know, that is the first angle or the first ply. Now we have to reverse it and put it at 90 degrees to that plies, to that. That's what it costs. And I want to show you how to do that. And by taking a full size of glass, in that we ensure that we're not going to have 2 butt ends on the same angle, in the same place from both plies. So this time we're going to start from this side of the shear web, and it will ensure us that a small piece right here will be on the other side. And here we go again. We're going to put it right in the center here, all over that. And here we go. And we get to a first line, which in this situation right here. And right here to the edge. And we're going to stretch it. And first line is right here. We have to get this 45 degrees. 45 degrees is very important. Here we go. Here we go. Here we go. we get to a first 45 degrees here and we stretch it. So far so good, looks very good. And we continue, spread it here. Oh, apply like this. Just in any situations when you work with the glass, do what you have to do. Don't let the glass to dictate you what it wants to do. Just put exactly where you want it. Put your hands like that and pull here. That's a line and that's the second line. And I pull along that. Very good. And I pull along that line. And that line here. Here we go. And don't panic in the beginning when it looks like, oh my God, something is going on. You will work. We're using a slow curing epoxy, structural epoxy, and it allows and gives it time enough to do work that it's necessary to be done. Here we go. And I know it's right here. 45 degrees, 45 degrees, right there, 45 degrees, very good, keep going. Here it is, here's the line. And here we go, we're almost done with this part. And one more here we go. So, you see, I have, what do I have here? I have nice 45 degrees. Look how I'm straightening them. They're straight. See, here we go. Here's the first bud. We're going to bud and continue to the other side. And with that, we will ensure that we don't have two bud what we call angles together in the same area. Okay? We're going to finish that and we'll get back to you with the next ply. Thank you. Hi. Okay, we finished the second layer of first ply. And the second layer of first ply was going this direction. I want you to, excuse me, so I'm taking, here it is, I'm sorry, this direction. That's a second layer of first ply. Here we go. The third layer will go exactly like the first one, and we go at the 70 inches mark right here. Center is right here, and we're going in that direction to 70-inch mark, and we placed right there, and let me just place all together right here on it. Here's a 70, and again the shortest end of this ply must be at the 70 inches mark. You know, when you guys will do that, some of you will probably think, oh my God, this is so complicated and it's so difficult. This is nothing. This is actually walk in the park compared to what you supposed to do on an original without the foil, which is very complex and very difficult curves and very difficult way of doing it, you know. This is a very simple way compared to original way to do, and we definitely suggest all of you to do this way. And you probably have no other choice because you won't have an instruction to do any other way. And it is significantly easier way to do than original. As you see, again, I'm to the line right here, and it allows me to straighten, and I pull both ways like this. It allows me to put my fibers exactly where I want it, exactly at the angle I want it. And I get to the next line right here, which is right here, and I pull it again, and it does allow me to control the glass the way I want it. Here we go. And don't let the glass to dictate you what it wants to do. You're going to put the glass where it must go. And here we go again. I straight, and I do it that way, and I do that way. Those ends like that. It lays very nicely, very good. And all we do, just continuing along this line. And that we are right now, as you can see, it's a parallel to this line, as parallel as I can. And it's very important to have this. Again, if it looks a little wavy, I stretch it this way, and it will get where it's supposed to be, which is 45 degrees. Okay, we're going to finish that layer, and we will talk to you a second ply of the second layer. Okay?
Shoot. We on? All right, I've replaced my Russian friend. I don't know how many of you may be aware of this, but Misha's building his Canard to, let's see, where's center line, gentlemen? Here's CL. And there's our 40 and our 40. Okay, we've cut bid here. I think that they probably already exposed you folks to this information. And I'm going to set it in between here. And Misha is rebuilding his crashed Berkut that went through a rotor in Jackpot, Nevada, and landed upside down on its right wing, bouncing it back to its main gear, flipping it over on its backside. It tumbled probably 6 or 7 times and landed upside down, never touching its belly. And the airframe survived and is rebuildable. The wings, Canard, are gone, the gear gone, but the strakes remained intact, and the cockpit kept the passenger and the pilot alive. And we might even give you a shot of it here in a little bit and show you what it looks like. No, I'll be all right, Misha. Okay. It's 40 inches of length. There's the center line, plus or minus 45. And we'll be back to you for the next ply in just a few moments. All right, here we go. Center line. I move with the grain orientation. I don't go this direction. If I do that, I just barely move the resin around without moving the cloth. Now this is actually the last ply before I get out my straight edge and my Olfa cutter. Now I've previously measured the shear web. And the shear web center, after tapering, on its backside is 6 inches wide. That's the upper section, the shear web, and the bottom section. And then at the tips, it tapers down to 4 inches. I'll use my inverted thinking here, and the upper edge is almost straight. It's the bottom edge that tapers. So we'll cut a straight line for the upper edge, and we'll cut a taper for the lower edge. And I just have to, but I have to reverse the foil process first. Because I laid it up exactly the way I would as if I was laying up on our standard solid foam core wing, which would be this direction. But in actuality, we're going to reverse this whole thing. So we're going to cover this with foil, and then we're going to cut it, flip it, and remove the back side so that, in essence, the layup will be reversed, and then we'll put it in the layup. We'll be back with you for that process. The machinations of trying to figure out what is the straight edge and what is the tapered edge. It doesn't matter because you can reverse it once you make your cut. We're going to run this straight edge, this upper edge, clearly on top of the glass so that you can see the edge its entire length. And if you're thinking, oh, what a waste of Misha, pick it up, pick it up, pick it up. Keep it up off the surface. Like, see the line?
Yes, sir.
Go to the line. Right there.
I'm at the line.
All right? And if you're thinking, oh, what a waste of aluminum foil, you shouldn't be building an airplane. Get the air out from underneath it. At this stage, it's not real critical because you're going to have to get rid of the air anyway once you're done the layup. Sort of work from the center that way and this way since it's the shortest distance. Okay, this is the center line, Misha, here?
Sir.
Okay. Measuring tape. Give me that short one right there. Okay, I'm going to measure down 6. And down here. And I'm going to measure down 4. Where's my end, guys? Is it here? Right there? Okay. Bang. Down 4. No, I'm not worried about it. Lay it down. Yeah, I don't care. I'm just making a cut, Misha. All right, now I need my good old cutter. Let's cut the ends off first. Zip. And okay, right there. Push firmly. You got to go through the whole thing. Let's cut this section down here. I'm an 1/8 of an inch or so I'm cutting through the aluminum foil. Believe me, plus or minus 1/8 of an inch at this stage, this is not going to make a difference as far as the ultimate strength of your canard is concerned. Okay, now on this line. And now let's cut the tapers here, Misha. Let's go this way. If we make a mistake, come on. We're making a mistake away from our part. All right. Grind this in. Let's see how well we did. this leaves the table pretty clean. Go for it. Now we've reversed our structure. Now we're going to pull our foil. This can be a bit of a pain.